Okay, good morning, guys. So today we're going to start to talk about what we call powers of products. So we spent some time talking about multiplication rules. We spent today talking about division rules. And today we're going to start to get into what happens if we have a group of parentheses and we have some exponents inside or outside, or in some cases both. So let's just review maybe the first three, okay? Because I know we reviewed this with the last lesson as well. So we know we're going to multiply our coefficients, and if we have the same base, we're going to add the powers of that base, which in this case we don't. So we're looking at 28 to the 6th c squared. For the next one, we're going to multiply our coefficients, which give us a product of 14. I'll add my powers of a, which is 0. I'll add my powers of b, which is 8. So we know that anything raised to the 0 power is 1, so a to the 0 power is simply 1. So we can rewrite this simply as 14b to the 8th. And for the third one and the last one that we'll do, we're going to multiply the coefficients. I'm going to add my powers of a. I'm going to add my powers of b. And if we want to get kind of fancy and rewrite this without using the negative exponent, b to the negative second, we drop to the denominator, we make it positive, so it's 38 to the 7th divided by b squared. So one thing we haven't really seen too much of is an exponent outside of parentheses, right? So we have a lot of cases in this, if you look at the do now slide, 1 through 5, tons of parentheses, tons of exponents, but no exponents outside the parentheses. So we need to think about what would that mean, right? So here's a good example. We have the quantity 5x, right, which is the product of 5 and x, is being cubed, right, which means raised to the third power. So what's actually happening here? So when I do this in class, if I say, what do we think? And I say, write down what you think, I get a lot of different examples. I get 125x. I get 5x cubed with the exponent just moves into the x. I get 15x. I get 125x. I get 125x cubed. I get a lot of different things. So let's see what we're actually doing. Well, this is the quantity 5x multiplied by itself 3 times. So literally, this would be 5x times 5x times 5x. So one of the things that I really like about laws of exponents is it's not necessarily a memorization game. And really nothing in math should be about memorization. It should be about understanding and deriving, right? If I forget, when multiplying or dividing, powers of the same base, I forgot what I do with my exponents, you can always expand it, right? And that's something I don't think I've really said enough over the course of the unit, but you can always prove your rules by expanding. And that's what I'm doing here. So this is one of those lessons where some of us, the rules are going to start to get crossed up, especially after the next lesson. So we're going to say, well, when in doubt, I'm going to expand it. And I may do this every time. So 5x is 5 times x times 5 times x times 5 times x. So the commutative property of multiplication says that I can multiply in any order. So I can do 5 times 5 times 5. And I can do x times x times x. Now, what if we don't want to do this every time? Well, let's think about what we did. Well, I had to do 3 powers of 5x. So I had to basically do 3 powers of 5. And I also had to do 3 powers of x. And 3 powers of 5 is 125 x cubed. And that's how we derive our power of a product property. And that's what we have here that we'll put in our notes. That if we have an expression that's raised to a power, we're going to raise each of the factors to that power. So ab to the n would mean I take, and sometimes people will say things like we distribute the exponent, which is not entirely, from a terminology perspective, it's really not correct, but it is what we do. We're going to take the n, which is the power, and we're going to apply it to both of those, which is what's going to give us a to the n multiplied by b to the n. And the same is true with numbers, right? We have the 2y to the 5th. So what did we do? We did 2 to the 5th times y to the 5th. And we can evaluate 2 to the 5th, which is 32. And y to the 5th stays as is. So what are we going to do here? Well, 4y is being cubed. So one thing I can do is I can do 4y times 4y times 4y. And I can do 4 times 4 times 4 is 64. And y times y is y cubed. But really what we want to do is we want to use the property. And the property says since I'm going to have 3 powers of each of those factors, 4 and y being factors in the product 4y, I'm really going to have 4 cubed times y cubed. And 4 cubed is 64 times y cubed. So it's a matter of preference, right? What I did in blue is actually using the rule, using the property, and what I did in green on the bottom is using expansion. And let's do the same thing here, 2xy to the fourth. So I could write out 2xy times 2xy times 2xy times 2xy. And what do I notice? I've got 2 times 2 times 2 times 2. I've got x times x times x times x. I've got y times y times y times y. But what do we really want to do? Well, we really want to apply the exponent of 4 to each of the factors, right? So 2 to the fourth, x to the fourth, y to the fourth, which as we said is 16x to the fourth, y to the fourth. Just make sure we apply the power to all of the terms. The biggest mistake I see is that people will just apply the y to the 4 because it's closest. I mean the 4 to the y because it's closest. And they'll come up with something like either 2xy to the fourth or 16xy to the fourth, and they say, well, what happened to x? Wasn't x raised to the fourth power too? The negative coefficient is going to be a little bit tricky. So it's probably a good idea to expand this, right? So this is negative 3x times negative 3x times negative 3x times negative 3x. So negative 3 times negative 3 times negative 3 times negative 3 is positive 81. X times x times x times x is x to the fourth. Now, if you want to use the rule, that's great. The negative 3 has to stay in the parentheses. All right, guys, if the negative 3 does not stay in the parentheses and you put this in your calculator, it will give you negative 81, which is incorrect. Okay, so since the negative 3 is in the parentheses with the x, you need to keep the negative 3 in parentheses. So negative 3 to the fourth is 81, x to the fourth, like we saw in gray above. All right, well, let's think about this one. This first one's a little, well, it's actually pretty easy. Expanding is not going to help for several reasons. One, because I don't want to write this 12 times, and two, because 5 to the 12th power is a really, really, really enormous number. So all I'm going to do is I'm going to say, well, this would be 5 to the 12th, a to the 12th, b to the 12th, c to the 12th, and I'm done. I'm going to leave it just like that, right? If the base, the numerical base, in this case 5 to the 12th, is too big to evaluate, we can just leave it as is. And this is the easiest one of all, right? I've got something raised to the 0 power. It's just 1, right? So that really shouldn't be much of a problem. We saw that with the last lesson quite a bit. This one's going to be a little bit tricky, and I don't want to get, anyone to get too hung up on this. We're really not going to see too much of negative exponents outside of parentheses, probably for another maybe 2 years. But let's take a look at it. So I've got 4 to the negative seconds. I've got x to the negative seconds. And I've got y to the negative seconds. Well, 4 to the negative second is 1 divided by 4 squared. X to the negative second is 1 divided by x squared. And this is 1 divided by y squared. So my numerator is 1 times 1 times 1, which of course is 1. My denominator has 4 squared, which is 16, x squared, y squared. All right, this gets a little tricky. So in these cases, it may be, unless the exponent is really big, it may be a good idea to write it out. Okay, so this is negative x times negative x times negative x times negative x. So I have a negative times a negative, which is positive, and another negative times a negative, which is positive, so I know my answer is going to be positive. Now what's the coefficient? Well, the only numbers that we don't really have a number, but we know that negative really means negative 1. So negative 1 times negative 1 is 1, times negative 1 is negative 1, times another negative 1 is positive 1. Do I need to write out the positive 1? No, I'm just going to write x to the fourth. Now, if you want to use the rule, this is how it works. You need to rewrite this as negative 1x to the fourth. So then we're going to say this is the same as saying negative 1 to the fourth times x to the fourth. And negative 1 to the fourth, since the power is even, we're going to have positive 1 x to the fourth. Now what's going to happen with this next one? Well, this next one then becomes tricky because we have negative x 3 times. So again, if I drop that coefficient in there, I've got negative 1 times negative 1, which is positive 1, times another 1, which is going to be negative. and x times x is x to the third. And you're going to see the same thing if you decide to use the rule, right? This is negative 1 times x, which is negative 1 to the third times x to the third, and negative 1 to the third is negative 1. So that's going to give us also negative x cubed. All right, guys, so there's your now try. So I'm sure we're all going to pause so we can work. And then we'll come back. So for the first one, we've got 7 squared times c squared. So 7 squared is 49, c squared. Now we've got negative 2x to the third. So I'm going to leave this in parentheses, and that's negative 2 to the third times x to the third. So negative 2 to the third is negative 2 times negative 2, which is positive 4, times another negative 2, which is negative 8, x to the third. Here we've got 2ab is being cubed, which is going to be 2 cubed, times a cubed times b cubed. And 2 cubed is 2 times 2, which is 8, a cubed, b cubed. For this next one, I'm going to have negative x is negative 1x. So negative 1 to the fifth times x to the fifth. And negative 1 to the fifth is going to be negative 1. So I should end up with negative x to the fifth. For this one, we've got everything raised to the fourth, right? 10 to the fourth, a to the fourth, b to the fourth, c to the fourth. I could probably leave it like that, but 10 to the fourth is 10,000. That's not such an enormous number. A to the fourth, b to the fourth, c to the fourth. For this one, I'm definitely just going to leave it. In other words, I'm going to say, okay, well, if I do 2 to the sixth times 3 to the sixth times 7 to the sixth, I'm going to leave it like that. Could you have done, I guess, 2 times 3 times 7 and put 42 to the sixth? I guess you could do that. It's not really what I had in mind, but you could do it like that. And then 7 we said was a little bit tricky, right? So we're going to raise each of these to the negative second power, which is 1 divided by 5 squared, 1 divided by a squared, 1 divided by b squared. So 5 squared is 25, a squared, b squared. Now, the only other thing I want to take a look at, and this is really just kind of an extension, kind of an aside, it's a little number theory, okay? So it says write the expression in as many different ways as possible. So once we learn our laws of exponents, we realize that there's most numbers, large numbers, any number that's not prime, I guess we could say, has multiple representations. And when you start to use laws of exponents, we start to come up with more and more and more representations of those numbers. So I'll explain what that means, right? So this is a pretty basic one, right? So 10 to the third, 10 is 2 times 5. So I can express this as 2 to the third times 5 to the third. Now, could I express this in other ways? Yeah, I guess. I could say that this is 2 squared times 5 squared times 10. I could say it's 2 times 5 times 10 squared, but for this one, I think I'll stop there, and I'll explain why, right? So for this next one, 20 can be broken down in a few different ways. We could say 20 is 4 times 5. So I could say it's 4 times 5 to the fifth, which would then in turn be 4 to the fifth, 5 to the fifth. I could also say that 20 is 2 times 10 to the fifth, and I could then call it 2 to the fifth times 10 to the fifth. And if I want to be really fancy, I could say that it's also 2 times 2 times 5, because that's also 20 to the fifth. And then I can say that it's 2 to the fifth times 2 to the fifth times 5 to the fifth. And then if I go a little bit further, 2 to the fifth times 2 to the fifth is 2 to the 10th times 5 to the fifth. So a lot of different ways that a number that like 20, which really only has 4 factors, but there's a lot of different ways, actually 6 factors, but there's a lot of different ways that we can represent some of these numbers. Now again, if this is too much for you, I really just want you to do your best with it, but I want to see if you can break the number down into factors and then just apply the power to those factors. So there's your homework, guys. I kept it pretty straightforward. Numbers 7 and 8 are what I just spoke about. So worst case, if you can break, let's say for number 7, break the 15 down into 3 times 5 and apply the power. Number 8, you can do it in a lot of different ways. So see how many different ways you can get for number 8. And then the rest of them, like I said, are fairly straightforward. Any questions, as always, guys, post comment on Google Classroom.